All right, here we go one more time. This is Mr. Longo, and we're going to prove trig identities for the third time. And these are going to be a little bit more complicated from time to time, of course. You know the drill by now. Make one side look like the other side. For this example, it would probably be better for you to turn the left side into the right side, but honestly, it doesn't matter by now. You should be able to pick whatever you want. So just see if you can do it. That's what we're going to do this video. No more hints on the first step. Just try it and we'll see what you do. Remember, there are multiple ways to do these. So if you get your answer in a different way than I do in this video, that does not mean you're wrong. It just means you took a different approach. Okay? So the first one, you should have noticed that the numerator on the left is a Pythagorean identity. Cotangent squared x can be written as cosecant squared x minus 1, and that of course is all over our 1 plus cosecant x. Now the next thing you'll notice is the fact that cosecant squared x minus 1 is the difference of two squares. So this would factor to cosecant x plus 1 and cosecant x minus 1, and that's all over 1 plus cosecant x. And that's equal to 1 minus sine x over sine x, of course. So what we can do here is cancel the two that are exactly the same. Now, cosecant plus 1 is the same as 1 plus cosecant. So those guys are going to cancel. So you're left with cosecant x minus 1 is equal to 1 minus sine x over sine x. And this is probably the part where you're thinking that you possibly just ran into a dead end. But you really didn't. Because, look, we just have a sine x over here, and this is cosecant x. So your next step should just be to just change this to 1 over sine x minus 1 is equal to 1 minus sine x over sine x. And remember, in order to subtract, you need common denominators. So to get a common denominator, you just have to change this minus 1 into sine x over sine x. So you have 1 over sine x. And remember, this is now sine x over sine x. So that's 1 minus sine x over your common denominator of sine x. So you're done. So sometimes when it looks like you have run into a dead end, you haven't. You just have to split something and get a new denominator or something, or sometimes you have to multiply by a clever form of 1. But that guy now is good to go. Number 2. This is one where you've got a whole big mess of stuff going on. So really for this one, you can work with either side again. You could try to get fancy and factor out a secant on the left side, but then, like I said, you're going to need to get fancy. This is an example where I would multiply the left side by the conjugate, a clever form of 1. Now, that means we're going to multiply the top and bottom by secant x plus tangent x. So if we do that, we're going to have secant x times secant x plus tangent x all over secant x minus tangent x secant x plus tangent x. And that, of course, is equal to our given. And now you need to look at what you can do here. So I would FOIL the denominator and distribute the secant x to the numerator. And that's going to give us secant squared x plus secant x tangent x. And you should see that we already have that right there. And that's going to be all over secant squared x And then, of course, negative tangent and a positive secant, and we're going to have a secant x and a tangent x. Those are going to cancel each other out because you have one positive, one negative. And then a negative tangent x times a positive tangent x is a negative tangent squared x. And that's equal to our secant squared x plus our secant x tangent x. Now, the numerator is the exact same thing as what's on the right. And the reason why is because this guy right here is a Pythagorean identity. Secant squared x minus tangent squared x is equal to 1. So you're finished. That's your last step. So we have secant squared x plus secant x tangent x, and that's equal to the exact same thing. So we're good. All right. Next one. The next one is a very easy example where you could work on both sides. Now, I'll let you choose, of course. You can do whatever you want. So just give it a try. But I'll just tell you that on the right side, you could multiply by the conjugate on the top and bottom. On the left side, you could factor the top and see what happens with that. So really, it doesn't matter. Do whatever works best for you. So I'm just going to factor the top left, and we're just going to have to think about what's going to multiply to a negative 5 sine squared, add to a negative 4 sine x, and we can easily do that, and of course multiply by 1. We're just going to factor that side, and that's going to leave us with 1 minus 5 sine x and 1 plus sine x. And of course, that's all over cosine squared x, which is a Pythagorean identity. The Pythagorean identity it would be equal to is 1 minus sine squared x. And that, of course, is equal to 1 minus 5 sine x over 1 minus sine x. And now, we could use the 1 minus sine squared x. What I'm trying to say is we factor it. So that's going to give us 1 minus 5 sine x times 1 plus sine x all over 1 plus sine x, 1 minus sine x, using the difference of two squares. And that, of course, is equal to 1 minus 5 sine x over 1 minus sine x. And you see the last step. Those guys just cancel. So you're good to go. 1 minus 5 sine x over 1 minus sine x. They're like little puzzles. You don't always know where your next step is going to be until you do something. And then you see what you have left. Always remember to factor. Always remember to have foiling. On this one, if you would have multiplied the top and bottom by 1 plus sine x, you would have had this in the numerator, and you would have had 1 minus sine squared x in the denominator, and you would have seen the Pythagorean identity. So this is exactly why this one is very easy to work from both sides. You don't have to be too clever to work from either one of those sides. Okay? Last example. Again, do it any way you want. I'm going to show you my way as soon as you try it on your own, and then click play when you're ready. My way is I'm going to multiply the top and bottom by 1 minus cosine theta. I'm going to do that to both the top and bottom. So we're going to have 1 minus cosine theta times 1 minus cosine theta all over 1 minus cosine theta times 1 plus cosine theta. And that's equal to our cotangent theta minus cosecant theta squared. And after we multiply all of that, our numerator is going to be 1 minus 2 cosine theta plus cosine squared theta, all over our denominator, which is going to be 1 minus cosine squared theta. And of course, that's equal to our cotangent theta minus cosecant theta squared. And from here, you should see that we have a Pythagorean identity in the denominator. 1 minus cosine squared is sine squared. Okay? So we're going to use that. We're going to turn that into sine squared theta. Now here's the cool little trick part. Remember what I told you about numerators at some point in time in one of these 3 videos is your numerator can be split to have a common denominator. That's what I'm going to do. I'm going to do 1 over sine squared theta minus 2 cosine theta over sine squared theta plus cosine squared theta over sine squared theta. So what I did is I split the entire numerator into 3 parts because that's how you add fractions. You just need a common denominator to do them. So that's going to leave you with cotangent theta minus cosecant theta squared. And this is where some of that's going to happen. We have 1 over sine squared theta, which we know is cosecant theta, or cosecant squared theta. We've got that guy. And now over here, this part is a little tricky to see, but if we were to split this into sine theta, cosine theta over sine theta is cotangent. And then, of course, sine in the denominator is going to jump up to be cosecant in the numerator. So that is a tricky step right there. But if you split sine squared into sine and sine, cosine over sine is going to give you your cotangent theta. And then, of course, your sine in the denominator is going to give you your cosecant theta. And then, of course, the last step, we have cotangent or cosine squared over sine squared, which we know is just going to be cotangent squared theta. And that's equal to this step, of course. So this part's tricky because you're going to want to switch these because this is cotangent cosecant and this is cosecant cotangent. But since they're both positive, you can just switch them. So by doing that, you now have cotangent squared theta and cosecant squared theta. And now you can just factor. That would give you cotangent theta minus cosecant theta times cotangent theta minus cosecant theta. And that's equal to this guy, which we know if it's the same factor twice, we can just write it once. So that's going to leave us with cotangent theta minus cosecant theta squared equal to cotangent theta minus cosecant theta squared. All right, that's it for this guy. This is Longo and I'm out. See you, bye.